Alright, I'm now on page 74. This is screencast number 2 for Unit 2, Lesson 1. Alright, under the blue heading, what do graphs show? Different types of graphs are used to show different types of information. On the previous page, you read about scatter plots. Bar graphs and circle graphs are other types of graphs. A bar graph is used to display and compare data that can be separated into groups. Okay. To show the overall pattern of monthly rainfall amounts, for example, you could display the data in a bar graph. Viewing the data in a bar graph could help you identify trends in the data. For example, you might identify periods of increased rainfall. Okay. A circle graph, what I often call a pie chart, is used when you're showing how each group of data relates to the whole set of data. It's perfect for when you're trying to show percentages. Okay, if you wanted to show the portion of annual rainfall that falls during each month, for example, you might display that in a circle graph. Okay, so number 8 says list, name at least 3 different types of graphs. Well, we've talked about scatter plots, bar graphs, and circle graphs. Okay, down at the bottom of page 74. Dwayne has been training for a race. At the end of each week, Dwayne recorded his best time for that week. From week 1 to 6, Dwayne's time in minutes were 9.5 minutes, 9.1 minutes, 8.7 minutes, 8.5 minutes, 8.0 minutes, and 7.3 minutes. Okay, so in the space below, you're going to construct a table to organize Dwayne's data. One column should show weeks, and the other column should show running times. Include a title and column heading for your table. Okay. And then on page 75, we're actually going to construct a scatter plot. Using the steps below, construct a graph to organize Dwayne's running data and draw a line of best fit. So you need to follow the steps. Number 1 is to title your graph. Number 2 is to label each axis with the name and unit for the variable that's represented on that axis. Step number 3 is to find the range for each axis. Step number 4 is decide the scale for each axis. Is one box going to represent 20? Is one box going to represent 5? That kind of thing. Okay. And for each axis, by the way, on the x-axis, all your boxes need to represent the same amount. On the y-axis, it can be different, but for all of the boxes on the y-axis, they need to be the same amount. Okay. Step 5, graph the points by putting a dot on the graph paper for each pair of data in the data table. And then step 6 is to draw the line of best fit. Okay. All right, so let me show you what I've got. Okay, on page 74, I have made sure that I underlined bar graph and highlighted it. I also found circle graph, underlined and highlighted it. And remember, I wrote out to the side pie chart. Circle graph and pie chart are basically the same thing, and they're good at representing percentages or parts of a whole. Okay. On number 9, down at the bottom, one of my columns is weeks. The other column is best time in minutes. And if you notice, I picked for my y-axis, when I do the scatter plot in a minute, my y-axis is going to range from 7 to 10 minutes. Okay. Number 10, identify, describe any trend or pattern that you see. Well, basically, the longer that Dwayne trained, the faster he was able to run. Now, obviously, if he keeps training, he's not going to get to the point where his time is all the way down to 0. But for right now, he's increasing his speed and he's running in a shorter amount of time. So let's look at page 75. And number 1, we titled the graph. So my title has to do with what we're looking at. Dwayne's running times for 6 weeks of training. That's the title. Okay, yours doesn't have to say exactly that, but that's basically what it needs to say because that's what you're graphing. You're graphing his running times over six weeks. Step 2 is to label each axis with the name and unit. My x-axis is weeks, and I spaced it out and did 0, 1, 2, 3, 4, 5, 6 so that I use as much of the graph paper as possible for that scale. On the y-axis is best time in minutes. And right here, this is one of those little squiggly lines, which means there's a break in the data. Because from 0 to 7, I'm not going to use any data points. And they gave me a 0 to start with. So I'm just going to put a little squiggly, meaning there's a break, an uneven part in the graph. And then I'm just going to go 7 minutes and 20 seconds, 7 minutes 40, 8, 8:20, 8:49, 9:20, 9:40, 10. Okay. So I decided on a suitable scale. And then I'm going to graph the points by putting a dot on the graph for each pair of data in the table. So at 1 week, he was taking 9.5 minutes. 2 weeks, 9.1, etc. So I've plotted all the points. And then step 6 is to draw a line of best fit. Okay. Notice again that my line of best fit shows a trend. It's not a dot to dot. It's a straight line through my points. It's kind of the best estimate of the slope for all of those points. Okay. Use the graph to formulate an explanation about Dwayne's running times. Do you see a trend? Yes. Generally, the longer he trains, the better his time gets. Okay. And then you're going to use the graph and predict when you think he will be able to hit a 6.5 minute mile. Okay. All right, and that's for you to do by yourself.